Thank you very much, Russell. Good morning, everybody. I hope everybody can hear me, and I hope everybody sees my screen. Thank you very much for the warm introduction. My name is Andreas Müller. I'm responsible project manager and team manager for the ESS system at BMZ. I'm working at BMZ since almost 10 years now. I studied electrical engineering at the University of Science in Applied Sciences in Aschaffenburg. And yes, it's an interesting product, brand new for all of us. And I hope you have fun today. What I plan during the next hour is I will introduce you to the battery technology itself, and of course, specifically lithium-ion batteries. I will introduce you to company BMZ. We are a young company, 20 years old. Short information what you can do with BMZ ESS 7.0, for example, at home or in business. And of course, I will bring to you the battery itself, the technical features, the possible system architecture, what kind of hardware do you need, what kind of software do you need. We will get to all of this. So first, starting with ABC of batteries, I'll jump over some points because they are partly very basic, and I'm pretty sure everybody of us is well aware of that. So what is a battery? A battery means two or more cells connected electrically together, different applications possible. In general, we talk about a cell which consists out of an anode, a cathode, a separator, electrolyte, a metal cam. We have two different types of batteries: primary batteries, which are non-rechargeable, and secondary batteries, which are rechargeable batteries. We at BMZ, we live in a world of secondary batteries, specifically lithium-ion secondary batteries. Of course, there are other technologies around: lead acid, niked, nickel metal hydrate. More or less, all technologies which have their applications. For example, lead acid, everybody knows that as a starter battery out of cars. And yes, of course, the technology increases, the development gets faster and faster, and new technologies come onto the playground. And I think lithium-ion is one of those, and let's say a very interesting one. All we do is connect batteries that lithium-ion ions can move from cathode to anode. That's everything. We have a separator between that makes sure that there is no physical direct connection between cathode and anode. You can call it short circuit. Yes. In a battery, we have, in most cases, of course in our case too, BMS, battery management system. This battery management system is an electronic system that monitors and controls the state of the battery. It protects the battery from operating outside. It has some standard features: voltage monitoring, current monitoring, temperature monitoring. It can have features like gas gauging, which is some kind of visualization of the state of charge, or the depth of discharge. It can provide some kind of cell balancing, and in most cases there is an algorithm implemented which calculates the state of health. In general, we say a battery and a BMS in combination is a smart battery. Maybe you heard that in the past. We talk about phones, smartphones, smart phones, and of course batteries are not dumb. Batteries can be smart as well. In most cases, they have to be charged by a smart charger as well. Yeah. Going back to the battery ABC, we do have cycle and cycle life. Those names, what did they tell you? A cycle means a complete discharging followed by a complete charging. Cycle life of the battery is given usually in numbers of cycles, after which 80% of its initial capacity has left. We call that end of life. What kind of cells are around? The most common cell is the cylindrical cell. It is very easy to produce, and it's very mechanically stable. It's a robust type of lithium-ion cell. The most common industrial used batteries from cylindrical cells are 18650, which means a diameter of 80 millimeters and a height of 65 millimeters, and 26650, which has a diameter of 26 millimeters and a height of 65 millimeters. Of course, you can overcharge those cells. That's not good. You shouldn't do that. But that means charge above a defined charge and voltage. That can lead to irreversible damage of the cell and a loss of capacity. Of course, this can be safety critical because the cathode active material starts to break down above 4.4 volts per cell. Usually we run this cell up to 4.1 volts to make sure that it's in safe condition and maximum increase of lifetime. Yeah, of course, you can over-discharge a cell as well, and you have to protect the battery from over-discharging. This means discharging below a defined discharge end voltage. This can lead to irreversible damage and loss of capacity of the cell as well, and also can be safety critical. In those cases, when you discharge a cell too much, a smart battery management system wouldn't allow to charge it again. What is very common, you all know that from your smartphones or from laptop, are pouch cells. We call them coffee bag cells or polymer cells. They have all fluid electrolyte absorbed in the polymer. They do not have a metal housing. They are extremely lightweight. You can use those cells when you have batteries only connected 1 or 2 or 3 cells in serial or parallel. But when we talk about big applications, it's, I think, not the best choice to use such kind of cells. In these cases, we should use cylindrical cells. Going back to the battery ABC, when I talk about a safety vent, it is an integrated opening mechanism that is activated to release the internal pressure in case of a malfunction. When the pressure inside the battery gets too high, we do not want that this single cell explodes. We want that this single cell opens the safety vent and the electrolyte and the pressure which is inside of the cell can go out. We have to prevent violent rupture. Yes, going back to the battery ABC, short circuit means a direct connection between positive and negative terminal. I'm pretty sure you all guys know that. Short circuit is nothing we should do on our batteries. This means high short circuit current is flowing, and in most cases this means damage of the battery or damage of a fuse which is integrated in the battery. All of this is not only lithium-ion specific. You will find that in every other technology around. What follows now is lithium-ion specific. I will tell you a little bit about lithium-ion cells, the advantages of lithium-ion technology: no memory effect, for example, no lazy effect, higher voltages, not 1.2 volts, where we know our NiCad or nickel metal hydride technology or lead acid technology. It's 3.7 volts per cell. It is very lightweight. It has the highest energy density, the highest efficiency, charging or discharging efficiency. You can use this technology in large temperature ranges from -20 degrees Celsius up to 70 degrees Celsius. It offers long cycle life and a low discharge rate, which might be an advantage, for example, for regions in the world where the temperature is usually hotter than expected. The structure of a lithium-ion cell, cylindrical cell, is like you see over there. We have a can made out of metal. Yeah, this one here. We do have a minus pole, we do have a plus pole. Inside, there's we call it jelly roll, and this jelly roll consists out of separator, cathode, and anode. Of course, the anode tap as well. Here you see a picture, top view, of an open cell. It is definitely the most common use design in the world. It is very easy to produce, highest energy density, very good mechanically stable, easy to contact. The disadvantages: it has a poor heat dissipation and the scalability is low. The functional principle is lithium ions move from cathode to anode and back from anode to cathode during charging and discharging. And this means these ions move and get stored into the active material in the cathode or the anode. When we talk about lithium-ion technology, you will see that there are many different kinds of lithium-ion technologies around. It is not one general lithium-ion technology. There are many different types. I think we all know those iron phosphate types, or olivine. Sony calls it olivine. We have manganese types around, cobalt, aluminium types here, manganese and nickel manganese cobalt, some kind of mixture. They all differ when it comes to nominal voltage, voluminic energy density, gravimetric energy density. Those technologies differ when it goes to discharging and charging currents. The cycle life is different. Of course, the manufacturing costs are different as well. And all of those technology you will find in different applications. Those applications can be high energy applications in home, high power applications. We all know that, power tools, garden tools, things like that. E-bike technologies, very big in Europe and in Asia. And of course, some of those types can be used in energy storage as well. most common are NMC technology and iron phosphate technology. When you have a look at the different technologies, we split that from high energy to high power applications, and you see the timeline from beginning from 2001 going up to mid of 2014. You see an increase of the capacity in every field. This technology is still moving very fast. Who are the manufacturers of those cells? Well, first there are the Korean companies like LG Chem or Samsung, and there are a couple of Japanese companies, for example, Panasonic and Sanyo. They merged together in, I can't remember, 2012 or 2013. And of course, company Sony is very big. And you have some Chinese types as well. Oh, Maxwell is Japanese as well. But Lishan, BYD, all of those companies, they come from China. The output of lithium ion cells worldwide is very interesting as well. You see here in million cells per year, 1,200 million cells by SDI, which means Samsung. Between 850 million cells per year manufactured by Sanyo, Panasonic, and LG Chem as well. Sony, around 400 million of those cells in 2014. When we look into a cell, we see that, of course, all those cell manufacturers more or less use the same technology, but everybody's doing it a little bit different. But what we usually have are intrinsic safety features which are implemented into each cell. Can be a PTC element, which means when the temperature increases, when the temperature of the cell increases, the impedance of the cell increases as well. That's some kind of prevention of too high currents. The next thing which is implemented in all of those cells is a CID. This CID means current interrupt device. If the internal pressure in the cell gets too high and increases, the electronic connection between minus pole and plus pole gets disconnected. The next very important feature is a safety vent. Safety vent means when the internal pressure inside the cell is rising too sharply, there is a too sudden effect of internal pressure, then this safety vent is opening. Opening means venting, and it prevents a violent bursting of the cell. All cells which BMZ uses, for example, have those elements. It's a must-have. Yes. Some safety features, it's a part of the cell, it's a separator, and this separator can have a, we call it shutdown function as well. When it comes to too high temperatures, for example, polyethylene at 130 and polypropylene at 160, the internal resistance of the cell increases at least at the factor 1000. This means it shuts down. The current is minimized. The cell itself has to be safe, but this is not the only thing which helps us to make sure that batteries always operate in safe conditions. Very important is the battery management system. This battery management system has a protection function, for example, overcharging, over-discharging, overcurrent, short circuit, over temperature, under temperature. It can have features like balancing, for example, when you have cells over the years, the internal resistance of the cell changes, and this balancing feature helps you to increase lifetime. The battery management system is responsible for bringing and giving information from inside to outside and back. This can mean, for example, a gas gauging function, and that can mean an error memory as well. In modern batteries, the battery management system has some kind of permanent error log. And that means that the manufacturer, when it comes to warranty, can very easily explain the customer what happened with the battery during the last, I don't know, weeks, months, years. For example, our battery management system at the BMZ ESF 7.0 has an 8 gigabyte internal memory, which can be read out. That means we can store data for 29 years. Every current flow, every temperature, every voltage level of each cell, the status of the relays, the status of the battery management system, all that is logged inside in this arrow. And of course, it's responsible, the battery management system is responsible for the communication. That can mean by different kind of bus types, M-bus, LIN-bus, CAN-bus, Mod-bus, whatever the application speaks, the battery has to follow. The structure of a BMS is more or less always the same. We have some kind of intelligence in the middle, and this intelligence got information from outside, from the cell or the battery, in most cases the voltage and the temperature and the actual current. All those information will be interpreted by the battery management system, by in most cases the microcontroller, and this microcontroller can turn on and off the energy path, in this case with a MOSFET for charge and discharge, also can be a relay, for example, 1 or 2. And in most cases it has a second protection device, which means the battery management system has a path for the microcontroller, which is controlled by the microcontroller, and has just had some analogous paths which are absolutely independent from the microcontroller. And you have a trigger. If you have a trigger event on the second protection line, you have to have some kind of irreversible fuse, which can be triggered by the analogous path. Here you can see, of course, the intelligence inside of the battery is responsible for the communication to the outside. Of course, it has to be. When we talk about correct handling, I think everybody of us knows what this means, but I want to make sure that it's written down. When lithium-ion batteries are handled properly with care, they can be considered as safe. Improper handling or technical defects may lead to uncontrolled release of stored energy. Of course, if you do that, there is a risk of fire. Please never do not open or dismantle or crush a battery. Batteries should only be opened by trained personnel. Do not short circuit a battery. In best case, only the fuse blows. But you will find batteries around which do not have a proper fuse. Please do not short-circuit batteries. Please do not expose lithium-ion batteries to high temperatures or throw those batteries into fire. Please do not expose lithium-ion batteries to mechanical impacts. Not good for the battery. Do not damage or those batteries, and please do not use damaged batteries. Very important. Do not use other chargers when specified. That can cause to overcharging. Please do not use batteries for non-intended devices. Please do not use batteries outside the specified temperature range. Please do not use lithium-ion batteries exposed to rain or liquid. Yeah. Do not use batteries if housing is broken or deformed. And so on and so on. I think that's very clear. I showed before there are many customers around, many suppliers around, which provide those kind of cells. The big ones in Japan, South Korea, and China. Of course, there are others around in the United States. We have K2 and A123, very well known. In Europe, you have the company Saft, which provides lithium-ion cells as well. But the big volumes, they come from China, from Asia in general. Now I think it's the right time to tell you a little bit about BMZ. We talked about batteries in general and lithium-ion technology specific. I have a very short presentation. Who is BMZ and what are we doing? I hope so far everything is okay with you guys. I cannot see the chat, honestly speaking. I only can see my screen. So if something shall be asked or occurs, I have to ask those guys from PROINSO who are doing a very good job, Russell or Mark or Jonathan. Please, if something is important, inform me.
Absolutely, Andreas, we can all hear you, so keep going.
Everything's fine?
Everything's good, thank you very much. We'll let you know as soon as a question comes across.
Okay, excellent. Then I will continue. Thank you, Russell. Yeah, BMZ. BMZ is a company. At the moment, we are 20 years old now. The headquarters is in Karlstein, Germany, which is 50 kilometers in the south of Frankfurt, Germany. We do have our own laboratory here. We do have sales, R&D, production, purchasing, quality, blah, 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 all those special departments around. We do have a 100% daughter subsidiary in Poland. They do sales, R&D, production, purchasing, quality. We do have a 100% daughter in Shenzhen. It's close to Hong Kong. They're doing production over there. They're doing development and production of chargers, which is very interesting for us. We do have a sales office in Virginia Beach. It's on the East Coast, middle of the East Coast. And all those companies together are the BMZ holding. Yeah. We started in 1994. In 2000, the lithium-ion technology got introduced, and we were more or less responsible for introduction of lithium-ion technology in Europe and in Germany. In 2002, we started with power and garden tools. Now we have around, I don't know, 80% of those markets in our hand. Between 2006 and 2011, we founded some subsidiaries in China, Poland, and USA. In 2011, the e-bike business got bigger and bigger and bigger. In 2012, we started with storage. And in 2014, we started with automotive applications, which is very interesting, I can tell you. Here you can see pictures of our buildings. I'm located over there. I'm sitting there. In total, we do have around 1,500 employees. The applications which we work on are, we do have many of them, different of them. Aerospace, automotive, mobility, emergency, gun tool, green energy, home applications, industrial applications, defense, of course, power tools, and UPS applications. The company BMZ is not very well known because in most cases we operate as OEM. We produce batteries for big companies, and here are some of our customers from the different areas, and I'm pretty sure you heard a couple of those. Okay, at that marketing blah blah blah. I will continue. Marketing blah blah blah. We do not only build battery packs, we do build chargers, we build motors, battery management systems. We do have Europe's biggest service center for lithium ion. We produce all technology which we need inside our own walls. We build up the manufacturing sites. We build up our own test equipment. Blah blah blah. We do have 4,200 different battery packs so far in production. We have 250 new projects every year. We do have 1,300 paying customers. Some bling bling for our management here and there and there as well. Very good. Sales turnover, BMZ Global. We are in year 2015 and 16, where we reached over 350 million US dollars turnover, and this year our goal is to be above 400 million euros. So this is BMZ. I will move to my own presentation, how to use BMZ ESS at home. Well, it's very simple. You need the battery, of course, for storing energy, let's say for evening or night, or if you have a bigger application for the day. This battery gets charged and discharged by a battery inverter. And this battery inverter can create his own grid if it's needed, at off-grid applications, or can be connected to the grid and feeding the grid if you have too much energy from PV, for example. So that means you need a battery and you need an inverter. In this case, it's a SMA Sunny Island, which is a very good inverter, I would say. The biggest inverter for battery inverters at the moment. It can be connected to the grid, for example, when you have only one sunny island and one or more batteries. It can be one phase. It can be three phase as well, if needed. And you can use more of those three-phase systems together if you have to have it, if you need it, to build up a multi-cluster, SMA calls it multi-cluster. So you can choose. It's a very flexible system. This sunny island is available in from the dimensions of from 3 kilowatts energy needed, power needed, up to 8 kilowatts power needed in single phase, and in three phase, I think up to 33 kilowatts. But that can be found on SMA data sheets or SMA training. As you know, I'm not an employee of SMA. We are compatible with other inverters as well, but I will come to that point later on. Yeah, you can optimize your energy bill at the end of the month, or you can create your own grid if it's needed, for example, in Africa and elsewhere in the world. So here we do have the products. We have two different kinds of ESS, I would say. We do have the ESS 7.0, which means 6.7435 kilowatt hours nominal energy inside of the battery. And we do have ESS 7 Premium, which is the same battery, the internal, the battery is identical, but you have a housing which is nicer or more sexy or whatever you want. Of course, this housing, because you have welded edges and not only banded edges like here, it is a little more, the costs are a little higher. But the function itself is identical. Huh? Yeah. It is, of course, environmental friendly lithium-ion technology, up to 20 years expected lifetime, cycle stable at high current. Yes, I think we have the most powerful battery in the market at the moment. Fast charging, of course. No memory effect, of course. Active temperature control, safety approved technology, latest standards, of course. Integrated multi-level safety concept. Of course, we talked about that before. We do have balancing, we do have voltage monitoring, SOC algorithm, SOH algorithm, compatible, for example, with SMA Sunny Island, Victron, Stude, Steka, others around. Ability for multi-cluster, yes, we do have that. Here are the technical data. I will not read that down. You can read that in your data sheets afterwards. Or ask me or ask the guys from PROINSO. They have all needed information, yeah. When we look at a BMZ ESS without the outer housing, we will see an inner housing. I know, boring, I know. Why I show you this is I want to make sure that you understand you have two separate metal housings, which is unique selling point as well. It is very robust. This outer housing, you can bring up 3 of those batteries onto each other, which is very good because it saves space. Yeah. Here you see the NH1 breaker, the fuses for external. When I open the inner housing, you see the cells, 3 levels of cells. You see the battery management system. You see the cable harness. These cables, they provide the information. They measure the information at the cells and provide that information for the battery management system. Yeah? You see here the current measurement. Here you can see the pyrofuse. This is the secondary protection cutting device. You see the main relay, military standard approved, very good relay. A melting fuse, and the NH1 breaker with, again, fuses for outside. We do have integrated 12 temperature sensors. I know I wrote only 9 because those 9 that information from those temperature sensors can be read out by the microcontroller. Those informations going to be stored at the micro SD card, and you can read out that data with a service tool. A Windows PC program, I will show that later. The other three temperature sensors are reserved for the analogous path, and you cannot read out those data. Yeah, here you see three levels, level 1, 2, 3. All those levels are, from the manufacturing point of view, identical, which makes it very easy for our production. This is one of those levels. You see 5 cells serial connected and 54, 54 cells parallel. Here you see a single, we call it cell string, which is 5S, in this case 11P. And this is the smallest, this is the basis of the battery. We produce that, and we connect it to that, and we connect it to that, and in the end, you have 3 of those. The connection of the BMZ ESS, I hope, or I think it's as simple as possible. You do have a plus pole, which is marked red, and you do have a minus pole, which is marked black. Those cables are double isolated H07RNF 50 millimeter square cables. We use a ring lock M8 to connect them direct to the inverter. You will see that afterwards. We do have a communication port for communication via CAN bus to the inverter. And we do have a USB connection port for doing service. For example, when you have to upgrade the firmware of the battery, or you want to read out the all kind of stored information can be read out by the USB port. If needed, or if we have time in the end, I can show that to you. Yeah, I think we can jump over that. The functions of those battery management systems, it's a self-developed battery management system by BMZ. We talked about that before. Single cell level monitoring, current monitoring, temperature monitoring, use a relay with contact monitoring. That is interesting. Yeah? If the contacts of the relay include, we can detect it and we can trigger the pyro fuse. It's important for us. We do have a derating algorithm inside, which is very good. We do passive balancing, active thermal management, state of charge, state of health, yes, communication, of course, data logging, yes. What makes this battery smart are a couple of features. One of those features is the derating curve. The goal of the derating function is to regulate the power output, minimize or maximize of the battery to optimize the thermal balance of the battery, and in the end, of course, lifetime. Yeah? The parameters which are relevant are the temperature and the state of charge. Let's say the battery protects itself from overheating, and it's working very good. Here you can see on the x-axis you can see the temperature. And what happens when we reach or when we trigger a certain level. For example, at 0 degrees, the relay opens, low temperature. At 2 degrees Celsius, we give out alarm warning, low temperature. Alarm message. In the world of SMA, alarm message always means no more charging and discharging. Or turn off the inverter, can also be. At 10 degrees Celsius, we do give a warning low temperature onto the CAN bus. At 30 degrees, we activate the fan. We do have a fan, which is temperature regulated from 30 to 50 degrees Celsius. At 40 degrees, we bring out a warning, and at 58, we activate the alarm message onto the CAN bus. At 60 degrees, we open the relay. The derating function has direct impact for the charging current. When the temperature is 55 degrees Celsius of the battery, you see that you will only get very, very, very little current. On the x-axis, you see the state of charge, and on the y-axis, you see the current. This means between 100% SOC and 30% SOC, you will have a derating from, still we are here at charging, from 90 to 20 amps. You have the same when it comes to discharging, higher temperatures, lower temperatures, SOC, and current. But you see the delta between charging, which is up to 90 amps, and discharging, which is up to 300 amps. When the battery is more or less cool and the state of charge is high, you can discharge the battery with really, really high currents, up to 300. I think no other battery in the market allows this at the moment. I put in this chart to show you, or to give an impression, to give you a feeling. When we talk about this battery, we read before that the nominal voltage is 55.5 volts, so we can charge up to 60 volts. But the battery management, the main functions of the battery management system work on cell level. This means we live in a world from 4.1 volts up to 2.9 volts. And within this range of voltage, there are many, many, many different trigger levels, and all those trigger levels do have functions behind, and those functions can help that the battery works in safe, stable conditions with long lifetime and all that blah blah blah. Oh no more safety concept. Yes, we talked about all of that. Every battery has a CID. We do have over and under voltage monitoring. We do have electric, mechanical, currentless open relay for redundant power cut of the battery in combination with secondary protection cutting device. We do have double metal closed housing, balancing of all serial strings of cells. Active current regulation is function of cell voltage and cell temperature. Yes, we do have all of that, and it's very good. It's a smart battery, and it's a very safe battery. What else? Yes, data logging, we talked about that. And of course, that's a big advantage. We offer a Windows PC, that should mean PC, service tool from BMZ to guarantee good service and customer care. And if needed, of course, we will share that program to you. I can show you afterwards. Here you see the PyroFuse. We call it PyroFuse. It's a second protection cutting device. You see the bus bar, and when it comes to a trigger event, when the battery thinks something is not working as it should, and you have to protect outside from the battery, or you have to protect battery from outside, both ways are possible. This cutting device will go into that bus bar, and yes, from that point on, it disconnected, and you have to call PROINSO. How many batteries to connect parallel to a SMA sunny island inverter system depends on what kind of inverter you have. We have small sunny island 3.0, 4.4, 6.8 point. You can use that in one phase or three phase. This means for the general system, you have different discharge powers available, up to 18 kilowatts, in peak 33 kilowatts. But of course, it makes no sense to connect to 3 sunny islands, the biggest ones, only one battery. It makes absolutely no sense. In this case, you should connect 5 or 6 batteries to that sunny islands. And when you have the small sunny islands in one phase condition, you can connect 1. That makes sense. Of course, you can technically connect even more, but it makes commercially no sense because that system would be too expensive. So PROINSO can offer you or can talk to you and give you some advices. When we talk about off-grid applications, we are usually talking about 3-phase with the biggest sunny islands, and our proposal is to use 4, 5, or 6 batteries in such cases. Yeah? What additional, we talked about the ESS battery during the last minutes, and I introduced you to the technology itself, and now we talk about parallel connection, because this is a unique selling feature of a battery. It is a very powerful battery, and it's a smart battery, but it can be used in parallel as well. And there are not many batteries around who can provide that to you. And I think we are the only one who provide that combination of power and flexibility. Yeah? You need some additional hardware for that, but the good information is this hardware does not cost much. You need a Y adapter for the internal communication. You need a patch cable, can be Cat5e, for example, and you need terminator resistance. Every terminator resistance is around, I don't know, €2, not that much. Important for the Y adapter is that the pins are like followed: 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. That is very important because there are other Y adapters around which have, for example, crossover function. Please do not use them. You have to have Y adapters. You can buy them at PROINSO. They don't cost that much. All those components does not cost much. You need these 3 additional hardware components: Y adapter, patch cable, and resistor, terminator resistor for the bus, for the communication. We talk about internal communication of the batteries. You have to connect them in parallel, and you have to make sure that they can speak to each other. To bring the power of those parallel connected batteries to the inverter, you need a second hardware. This is, we call it bat breaker box. SMA offers its bat fuse. You can use that as well. We are fine with that. But you can choose our product as well. Bat breaker box, and that bat breaker box, blah blah blah. It's available since March 2016. Yay! It is easy to parameterize. Parallel connections up to 6 ESS batteries possible, and you can choose. We have different sizes of those when you connect 2 or 3 or 6 batteries in parallel. This picture here shows 6 batteries in parallel. You see those copper bus bars. Here are the connection for the plus pole of the 6 batteries, and here is the connection point of the minus poles of those 6 batteries. You have plus pole, bus bar, minus pole, bus bar, and here you connect the inverters, plus pole and minus pole. It is very simple, honestly. And even those butt breaker boxes, they do not cost that much. So, when it comes to the communication of the parallel connected batteries, we have external communication. This is no matter if it's one phase or three phase, or one battery or six battery, or one SMA inverter or three. We have a CAN bus. This CAN bus communicates between SMA inverter and BMZ ESS7. And we do have an internal communication, you can see over there. Physically, it's RS485 bus, and this communication is for battery internal communication. And here you see why you need those Y adapters and the terminator resistance. It's a bus system, and this in the beginning and in the end of this bus system there has to be a terminator, and you need the Y adapters to bring the communication from battery to battery to battery. On each battery there's only one internal communication port. Here you need the butt breaker box. Once again, this is only communication, and this is connecting the power, plus pole and minus poles. And on the butt breaker box, you install the BMZ ESS batteries, 1 to 3 stacks, and you install the SMAs on the island inverters, 1 to 3. Master / slave. Same, very important, here at the battery, you can use the BMZ service tool for doing the parameterization. In each system, it's only allowed to have one master. Every other battery has to be a slave. Slave, 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 slave. Very important, each battery has to have a unique device address. 1, 2, 3, 4, 5, 6. You can also choose 3, 4, 5, 6, 7, 8. It doesn't matter. So, next important for you, and I name it directly now because it's important for us and important for you to give you best technical support and enable us all to guarantee longest lifetime. Very important, the maximum length of the power connections between the battery and the butt breaker box. Please, no longer than 2 meters. The recommended cable cross-section is 50 or 70 millimeters square. Never, never, ever make these cables longer. And very important, those lengths of the cables have to be always the same. Between each battery, plus pole, minus pole, and between other batteries as well. The length has to be identical. We are living in a DC world, gentlemen, and this is very important for us. The same is the length from the butt breaker box to the SMA sunny island. Please no longer than 1.5 meters. Same rules, cable always the same length. Each cable, every battery, always the same length. So, this is the introduction of the service tool. I'll make it as short as possible for you guys because we are 12 o'clock. This is the Windows PC service tool. You can read out battery information. You see firmware version, hardware version, PCB version, bootloader version, serial number, date of manufacture, how many cycles, what is the design capacity, full charge capacity, blah, 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 state of health, state of charge, and the actual current which is flowing. When you go to that point, you can download all data stored so far. From the beginning, from the manufacturing at BMZ, you will see those data. We charge and discharge the battery here at our manufacturing site. You can see those data, and you can see the complete performance data of your battery for theoretically 29 years, which is long. Here you can do the parameterization of the parallel connection. And you can create a PDF report. Let's say a PDF report is some kind of snapshot of the battery. That is nice when it comes to questions. What firmware actually is running on the battery? Please create a PDF report. You will see all needed information inside. This tool, log data and PDF report, is very, very powerful when it comes to service. Yes, of course, we are compatible with the SMA Sunny Island product family. Of course, we are compatible with other inverters around as well. For example, Victron Energy, Steger Coolstep, Studer Solar Inverter, and or NEADUP inverters. We are using different platforms, online platforms, so that not every inverter manufacturer has some kind of online platform like Sunny Portal from SMA. What is needed, you can use Kiwi Grid or Meteor Control, which provide that service to you as well. And we are compatible with that online platforms. Installation, plug and play, very easy. Ring lux, 50 millimeter square M8, plus and minus, I told you, red's plus, black's minus. That'll be directly connected to this is a picture of the SMA Sunny Island. You have a patch cable for the communication. You have to have NH1 fuses. And this is the push button with a red and a green LED. When you push that button for longer than 1 second, the battery will wake up. If you push this button longer than 10 seconds, the battery will shut down. Everything, and again, very easy. Here you see some sample installations of our battery in combination with Sunny Island. I only show pictures from parallel systems because single phase systems are let's say more or less boring. Here you can see this one is off-grid solution. It's standing on the island, the beautiful island of Malediven. And this one here over there. Oh, it's red. It's a BMZ battery as well. We have different colors for that. This is a battery from IBC Solar, and it's a 3-phase system. And it's for building a grid and current bill optimization for agricultural manufacturing sites. Yes, that's all, gentlemen. Thank you very much for your attention. Of course, please feel free. We have a booth at the Intersolar Europe in Munich. It'll start next week, Wednesday, going to Friday, 24th June. Hall is B1 at booth 452. You are all invited to visit us. And yeah, that's it. I'm at the end of my presentation.
Fantastic. Andreas, thank you very much for your time and for your insight into the battery technology. I think it was great. Right now, I think it's best if we ask any questions. Chandra, will you just mute anyone who's not muted? I hear feedback. But if anyone has any questions, please feel free to put up your hand. If you just push, there's a little hand next to your chat box. And we will obviously then attend. So Vessel has a question. Chandra, please unmute Vessel, and then you can ask the question.
All right, thanks guys. I just want to know how frequent is the firmware update, And what is the recommended service interval? Is it time-based, or how do you prepare the service intervals?
You talk about firmware. Yeah, difficult to answer. During the last year, where we started the sales activities for that product, we had firmware updates when we had to answer, for example, firmware updates from SMA. It comes, I say, 2 to 3 or 4 times per year. SMA, for example, provides firmware updates, and in I would say 50% of the cases, we have to modify our firmware as well when SMA provides a firmware update. Or the second one is when we have to do bug fixes. It occurred a couple of times during the last year. We have no firmware delivery specific dates. I hope this answers your question.
Thank you.
Does anyone else have any questions? No, doesn't look like it. Okay, fantastic. If anyone comes up with any questions sort of at a later stage, please feel free to send them through to us, at which point obviously we will then address the questions, and we can obviously forward on to Andreas and ask him if it's a little bit technical if we don't know the answer. But in general, Andreas, thank you very much for your time and your insight into the battery technology and BMZ in particular. I trust everyone found it quite informative. And yeah, our next training event will be on the 14th of July about structures. I think it will be also quite interesting, and we'll delve into a little bit of depth around how to size systems and analyze and obviously incorporate them to different conditions. Yes, so we look forward to seeing you there. There'll be invites going out shortly. Thank you everyone for your time, and I trust you have a good day going forward. Thank you, Andreas.
Thank you very much, gentlemen. Have a great day.
Thank you.